Hi, this is Scott Frazier, and I'm going to demonstrate this implementation of Tim Conway's Game of Life. And if you don't know what it is, just go to Wikipedia and search for Game of Life. It's an old cellular automaton simulation, and they have a nice entry about it. What you see here are three windows from one program. The window on they're all starting in the same state, so I've got the exact same starting state for each life simulation that's about to run. There's a window on the left that's going to have one thread, there's a window in the middle that's going to have two threads, and the window on the right is going to have four. And down at the bottom you can see the 8 CPUs from this is running on an Intel i7, which has 4 hyper-threaded cores, so it looks like 8 CPUs, and that's what we're going to be running it on. And when I kick this off, one of the things you'll notice right away is that the window on the left will only have one color, the window in the middle will have 2 colors, and the window on the right will have 4 colors, and that's because I've got each thread using a distinct color as they process the simulation, and that way you can kind of visually see what's going on. And you'll see right away that the 4-thread window is going to pull ahead of the other two, and eventually the 4-thread window will get to some steady state of some sort, which is what usually happens in this simulation. And eventually the middle window will get there, and then finally the last one. So let's get this thing rolling. I'm going to click on the start button. Again, they're all in the same JVM together, but different sets of threads are processing each window. And right away you can see that the window on the right is really moving a lot quicker than the other two. And if you look at the CPUs down in the top display down at the bottom there, you'll see that they're all very busy. And actually it's kind of funny, if I look at how many watts my machine's drawing right now, it jumps up like maybe 90 watts when I run this simulation and get all those cores busy. And it's a pretty clear illustration of how having more parallelized tasks get you to whatever your end state is quicker. What I'll be showing in the talk that I give about Clojure is how I was able to take this simulation I based on an implementation that a guy named Larry Sherrill uploaded to the Clojure Google group, and the initial implementation had multiple threads, but didn't actually parallelize the heavy lifting. So I took it and parallelized it and added the coloration, and then also added this ability to have multiple windows open with different numbers of threads in each window, so that we could see the effects. And you can see the window on the right now is at that steady state. The window in the middle should get there pretty soon, and then the window on the left is bringing up the rear. So I hope you've enjoyed this, and I'll just let this play out.